This is my microcontroller powered prime number generator. The number it's currently displaying is represented by the powers of 2, which are illuminated by the small lights. If a power of 2 is illuminated, you add it, and then the total number that it makes when you add all of the numbers together represents a prime number. You can see the number slowly changing from one prime to the next prime. When you have large numbers like this, which is way over 20 million, it takes a long time to test every number and determine new prime numbers. The smaller the number is, the faster it goes. So I'd say it generates about one prime number every 10 or 15 seconds at this rate. So let's open it up and see how it works. Inside we have 5 rows and 6 columns of LEDs, and all of these LEDs are not on at the same time, but I'll talk more about that later. Each row is controlled by a transistor, and each column is also controlled by transistors here. These transistors cycle power, or high power, from these 3 batteries to supply positive voltage to the LEDs, and then these transistors allow the microcontroller, which is the part of the circuit that we actually program with our software, to control the grounding. So when an LED is provided with both power and ground, it illuminates. The microcontroller is powered by these 2 batteries here. And we also have some circuitry for a small regulated power supply, so we could hook it up to DC wall power, but I'm not going to worry about that. We've got a small button here which goes into some menu functions I'm not going to talk much about, and a small 10 MHz oscillator which is used to power the crystal and set a steady time base. So we also included some small pins here which I can hook up to allow us to connect this microcontroller directly to a computer to allow it to be programmed with the software. So I'm going to do that now and show you some of the different things that we can do with the microcontroller. Okay, I've finished connecting the wires that go to the computer, and these wires just go straight through to the parallel port, or the printer port, and one of them is blocked by this switch here. When I push the switch, it turns on the reset button, which resets the program, and I also have to hold it down if I'm going to be programming the chip. I've programmed it right now. When it resets, it displays all LEDs on, and this will be useful in a second when I show you a piece of software and how we can load it onto the microcontroller. Now I've written the software so that we can change this value here, delay. Normally it's 1. When it's 1, the microcontroller looks like this. All of the LEDs are visually on at the same time, and we can't really tell how the multiplexing is working. If I change this value to a higher number, like 50, and then I can program it, hold down the reset button, and you can see it's compiling and then loading it onto the microchip, and now it should be on the microchip. It slows down the process so we can see how it's actually generating the lights. It uses this technique of doing one column at a time very, very quickly, and the persistence of vision is what lets us see it as one solid image of all of them on at the same time. So I'll program it again with a smaller delay value, and you can see it's running a little bit faster, but you can still see the flickering when that delay is 10. I'll just make the delay 1. Program the microcontroller. Microcontroller is getting programmed, and that's our result. The LEDs are pretty dim compared to the room light because they don't have a lot of current to each one. That's something I can increase in the future. But that's the basics of how it works. Now this guy doesn't look really impressive right now because when it's generating prime numbers up to 20 or 30 million like it is right now, it doesn't go very quickly. It has to test every number between 2 and the square root of this number, which is 30 million, to see if it can be divided into the number being tested to test it for primeness. This means that new prime numbers are only discovered every 10 or 12 seconds. But if I decrease the starting number down to about 5, so it actually starts looking at prime numbers starting at 5, you can see and appreciate how fast this program really does run. So I'm going to program it. It's programmed, and you can see it's practically flickering with all these prime numbers. Every time the value changes, it means it identified a new prime number. The smaller the prime number is, the faster it goes. Now it's generating prime numbers up to 2 to the 14, which is about 16,000, and it's still going pretty quickly. The first E turns on or off after every 10 prime numbers are identified. The second E turns on or off after every 100 prime numbers are identified, and the third one after every 1,000 prime numbers are are identified and so on. This gives us a way to determine how fast it's running without actually trying to count the number of times the image changes. So that concludes my little description of the prime number generator. We'll take all the programming wires out for now, rip all these guys out, close it up, and now you've got a cool little project to carry around with you if you want to look really dorky. So there you go, prime number generator. I haven't actually tested what happens once it gets to the last prime number, but I think it'll take several weeks to do that. So if anyone wants to try the code, try my project, and let me know what happens, that would be great. Details of this project, including schematics, more pictures, and even the source code, are available at my website, www.swharden.com.